So in multi-level indexing, we'll see into detail how is multi-level indexing done by using B-trees. Here, in multi-level indexing, we can also call it as multi-record indexing or multi-level indexes. Okay, here because we mainly see an approach where we try to introduce multiple levels of indexes or index files. Okay, here how does it actually help us or how does it improve our improves the performance. Here it actually tries to reduce the number of disk access required, and it also improves or minimizes the space cost. Okay, the space used and the cost due to the space usage. Okay, and then the next one is it actually improves the insertion and deletion procedures as well. Okay, the next is what are the different trees or tree approaches which we have seen so far, and because of what we have now go into B tree. First, we have seen a tree where trees have helped us to some extent, but it always kept adding some problem whichever we were not able to solve. So we went for paged tree. There also we ended up with an unbalanced tree structure because of selecting a bad route. Okay, and so we went for the next approach, that is multi-level indexing. Here we had insertion and deletion, creating making it very costly. So that is why we always wanted an ideal solution which helps us which gives us a very advantageous operation. Okay, that is why we go for B trees, which helps us give advantage, okay, to a solution. So we'll see with the problem here. Consider that we are having a file of 80 MB that is having actually 80 lakh records, and we are considering that each record is having 100 bytes and each key is of size 10 bytes. Okay, we are trying to have an index file where we are trying to solve or we are trying to save 8 lakhs key reference pairs inside this index file. Okay, so we are saying how can we save an index file for 8 lakh records. Here we mainly try to introduce a 4 level of indexing. Okay, and how is it done? For the first index file, we try to maintain a record which is having 100 records. 100 data means 100 number of records. Okay, the first index file's first record will be having the data for 100 records, and then similarly you can tell that the first index file is having how many records? It will be having 80,000 records, because each record will be having the key values of 100 records, okay, of your data file. Similarly, we again keep creating secondary index file. Again, in your secondary index file, it takes again 100 keys from your primary index file, and that will be the first record of your secondary index file. So similarly, there also we end up having 800 records. Then we go for the next, that is a third index file, where we again try to maintain each records of 100 keys. So we'll be ending up having 80 records. And then we go for the fourth level, where we're having one record which is having 8 keys, which is pointing to the third index file. So this is how we are trying to design our 4 level index file for 8 lakh records. Okay, so this is how it looks like. For this, consider that I'm having a data file of 80 MB, so it is having 1 to 80 lakh, 8 lakhs of records. And the first index file is like this. Now it will be having pointers, or it is having a key which points to the first 100 records of your data file. Okay, so this is how it looks like. So it is having 80,000 records which is having keys for your 8 lakh data. Now we go for the second index file, that is this one. Here we are again having how many? We are having again every records are having 100 keys. Okay, 100 keys. Now again it comes to having 80 records, 800 records which is having 80 keys. Okay, so this is how it looks like. This is in the case of second one. Now we go for the third index file where we again having 100 records, 100 number of keys per record. Okay, here we are again having 80. Okay, 80 records. Okay, and then we go for the fourth one where we are having a single record which is having 80 number of keys. Okay, so this is how our 4-level indexing works. Now, considering the cost of your multi-level indexing, we can tell we are having cost problems with mainly three areas. The first one is space, which is being used by the data saving procedures. So we can tell it is nearly, we need to save 80,000 records plus 800 plus 9. Okay, records need to be saved. So it takes actually this much of space to do the algorithm or do the procedure for you. So it take really 1% of the cost. Okay, and the second one is about the search time. We mainly need to consider three types of searching, that is minimum search time, maximum search time, and average search time. When you consider these three search time, we can consider that for every search we need to exist, whether the key exists or not, we need to search 4 levels of index files to know whether that particular key is there or not inside your data file. Okay, so that is what it takes, nearly 10% of your cost. The next is for insertion and deletion. Now for insertion and deletion, as I've already explained, we need to do the updation for your 4 levels of index files. Okay, considering from the smallest file to the largest data, we need to keep updating every file. Consider that we are having a smallest new key first. Now that is added into your first record. In that case, the largest key of that should be shifted to the second record. Similarly, every index files must be updated. So you can tell it takes nearly, in the case of first index file, it takes nearly 80,000 read or write operations when you do an addition of new key, addition of one new key into the data file. Okay, so this is the case of a cost. Next, we go for the basics of B-tree. Now, how does it work? In the case of B-tree, not similar, in the previous case we have seen that everything was up to down. Here it is from upward from bottom. So it is bottom to up approach that is being used by B-trees. Now, because of this approach, it allows the root to be emerged. In previous cases, we have seen that since we are making the root itself first and then we're trying to add up the leaf, we end up having an unbalanced tree. Here, we try to make our root emerge by doing different possibilities of rotation, so that the root, the correct data must, the correct key must become the root, so that the tree will become balanced. So in this case, we can tell multi-level indexing has been used, which actually helps in improving our insertion and deletion, and it is the standard way of representing our indexes. So B-tree will help us with providing solution for our insertion and deletion as well. So here, what happens in B-tree? If consider that an overflow of a record happen, if a record is having a size maybe 4 and we need to add one more data to the first record, in that case what happens? Usually what happens means we'll split up the record into 2. Okay, where consider it is having 4 records, it will be divided into 2, where 2 records will be having 2 values, and then we'll add the record or add the key to the respective records. Okay, this is in the case of insertion. Okay, now in the case of deletion, what happens? If it is deletion, we try to delete a value from a node, and if it is an unnecessary node, consider that it is having only few datas inside one particular node and wastage is there, we can just go for merging 2 nodes into one because of deletion. Okay, so that we can reduce the wastage of space. Now in the case of each node of B-tree, it actually represents an index record. A record is maintained for every node which is present inside your B-tree. The maximum number of key reference space which is available in your B-tree is known as the order of the B-tree, and the minimum number of key reference space which is available inside your B-tree is known as half of the order. So consider that I am having in one record I am having 100 keys. In that case, the maximum order will be 100 and the minimum order will be 50. Now, in the case of, we'll just consider how is insertion done in the case of B trees. If we consider that I need to enter a large value inside my B tree. Okay, in that case, what happens? Well, first I'll enter it into my first record. If the first record is this larger value is the largest one in this record, what I need to do means I need to put this value into the higher level and do the updation for the higher levels as well. Okay, and consider the case that I'm doing an insertion into a record which is actually having maximum of 4 data, but I need to add this data as well. So as I've already explained before, I need to split the record into 2 and then add the record and add the key. Now consider the key that the key is again after splitting the record, it is the largest value. The largest key is present there. In that case, I need to promote the largest key into the parent and then do the updations for the parent as well as for the child. Now this procedure of promoting the largest key to the higher level is known as promotion. Okay, now because of this promotion, it happens that the higher level again get overflowed. In that case, again I need to do splitting and then I need to do the updation for the higher levels as well. It keeps going if it is necessary. This is how the multi-level indexing happens in B tree. Thank you.